Hi, so this is a video for Assignment 6 for Cyber 411. So the first thing I'm going to do is once I logged into Portswigger Academy, I open the lab using the embedded browser. Then I navigate to any blog post, as you can see, so I can access the comment section. So the first thing I'm going to do is I'm going to go down and one second. Okay, I'm going to go down and as you can see, there's a leave a comment section, and then over, like if you scroll down to the bottom, there's name, email, and website. So I'm going to write down something there. And then once I do that, I'll be able to write on the comment section. I'm gonna write a I'm gonna determine whether the server is improperly handles HTML input by using a harmless formatting payload. Then I'm gonna write down. And then once I'm done doing that, I can post the comment, and then you can see that it says thank you for your comment. So it has been commented. And then now, and then that prefix that I showed you helps break out any existing tags, allowing my HTML to render cleanly if the site is vulnerable. And then now that we've confirmed the vulnerability, I can proceed with the actual malicious payload, which I wrote down, as you can see in the comment section. And then now I have submitted the comment, and the payload attempts to execute JavaScript via the one error event of an image element. So for the next part of the lab, I'm going to work with a vulnerability where the JavaScript code reads values directly from the location.search and passes them into document.write, which is an unsafe sync that renders raw HTML. So I'm going to start the lab and open the browser inspector. Then I'm going to try typing any text into the search bar. So then I observe that the input is reflected inside the src attribute of an image tag. So I went back here to make sure what I'm doing is right. So I'm going to do that again and see if that works. And let me try doing that. And as you can see, this command over here, And then I attempted an XSS payload using this command right here that I wrote on the search bar. As you can see right now, I'm going to type it in. So I'm just going to paste it. And because the application does not escape HTML characters, this payload successfully breaks out of the src attribute and executes JavaScript. So the result is a pop-up confirming that the DOM XSS via document.write and location.search has been triggered successfully. So now for the second part of the lab, we're going to explore how modern web applications attempt to block cross-site scripting attacks and how security testers analyze those defenses. So the goal is to understand how a web application firewall responds when potentially unsafe HTML tags or attributes are used inside a user-controlled input field. And we're not exploiting anything here, but we're just observing how the application actually reacts. So after I opened the lab through Burp Suite's embedded browser, I activated the proxy interception, and I entered a simple test payload in the search box to see how the application filter tags. And the response I received was tag is not allowed, which shows that the application detects certain HTML elements and blocks them. So next thing we do is we move to Burp Suite's HTTP history here, and we can see that the exact request the browser sent and how the server responded. Then we want to click Start Attack. And the intruder runs the prepared inputs one by one. Since this is Community Edition, the process runs slowly, but it still works. So now over here, we're gonna craft a response. So we watch the results table to see how the server responds. Most payloads return a 400 bad request, meaning that they were blocked, and a few may return 200 OK, meaning that the application accepted the input. And then I'm gonna go ahead and view the exploit. So now for the next part, once we're logged into Portswigger Academy, we start Burp Suite and open the lab using the embedded browser. So after we click the access the lab button, the store page loads showing multiple products, and we can select any item by clicking view details. And when the product page opens, we look for a button labeled check stock, as you can see right now. We click on that. To analyze how the page works, we right click the element and choose inspect. So we're just gonna click on inspect. So inside the inspector, we find a script that dynamically builds the select element for store locations. The script reads the store load parameter directly from the window.locations.search using URL search parameters. So we immediately spot the issue. The input from the URL is inserted inside an option element through document.write without sanitization or encoding. So this means an attacker can manipulate the URL and inject arbitrary HTML or JavaScript into the generated select box. And to confirm this, we can modify the URL by adding the store load parameter. For example, we can change it to ABCDE. And then when the page reloads, the drop-down button now shows our injected value, proving that the input is directly written to the page. So since the value is placed inside an option tag, we need to break out of it. And to do that, we close the select element and inject an image tag within one error event. So first we encode our payload, so we can write image source equals one error equals alert, and then parentheses 1. And then encoded version would be image percentage 20 src equals 1 percentage 21 error equals alert parentheses 1. So we can see the URL to see that we encoded our payload, and we can concatenate this after breaking out of the HTML context using what we see in the bottom. Then now we can replace the store load in the URL with our full payload, and when the page loads, the JavaScript writes our injected string into the document, breaking out of the select element and executing the alert1 payload. And then now we can see that the pop-up confirms that the DOM-based XSS attack was successful.